All right, I was asked about numbers 5, 6, and 15 on the Finding Redox homework, so I'm going to take you through the solutions to these. Remember that it is often helpful to determine the type of the reaction. There were some guidelines to that in the written lesson. So number 5 here, we've got a decomposition, and we should see that immediately when we see there's only one reactant. And the guideline with decompositions and synthesis reactions was that usually they're redox if there's an element. And we have an element right here. So there's a glaring clue that this will be a redox reaction. And usually if there's not an element, it might not be, but you can always check with oxidation numbers. So we know oxygen's a 0 here, and I'm going to try to type in some oxidation numbers. This is going to be a little sloppy because things are going to move around, but that's a 0 there. So oxygen over here is, as always, a -2. So there's our oxidation, increasing from -2 to 0. So something has to be reduced here. And this is where we use the idea of a species. And if you look at magnesium, magnesium is the same on both sides. You should recognize this as a magnesium ion and that as a magnesium ion, just with different anions. So that's not going to change. But chlorine here is part of the chlorate ion, and here it's a chloride ion. And almost always when there's a change of species, we're going to have a redox. So this one's the easy one. Chloride is -1 here. So the only other question is, what's chlorine here? And we definitely know chlorine is going to be reduced because when chlorine is bonded to oxygen, chlorine is going to have a positive oxidation number. Whoops. So right away, chlorine is going to be reduced to this -1 over here. And to find the actual oxidation number, you just have to go through the processes that we did in yesterday's activity. I would probably treat this as a chlorate ion that has to be -1 overall. And there's 6 negatives in the 3 oxygens. So this has to be a +5. So that's where we would get that. But again, you can identify where the redox is going to be well before you actually assign the oxidation numbers. Number 6, this is a synthesis reaction. And we just mentioned the general guideline for synthesis and decomp. Usually if there's an element, it's a redox. And if there is not, it's usually not. So there is no element here. So this one's probably not a redox. And just in case it was, if you start looking around, well, sulfur here is in 2 different species. It's in sulfur dioxide, the molecule here, and in the sulfite ion here. So that's a possibility. Okay? But the only 2 other elements are hydrogen and oxygen. And we said hydrogen, oxygen, and fluorine rarely change in oxidation number. And if you find them in an unusual state, obviously the elemental state means they're going to be involved in the redox, like here. But if it's not in the elemental state, you'd be looking for something weird like a hydride or oxygen bonded to fluorine or a peroxide. And we don't have any of those things here. Right? So this one's probably not going to be redox. To be sure, you go ahead and you assign your oxidation numbers. And again, in that process, oxygen in a compound is going to be -2, and hydrogen is +1 and oxygen -2. Okay, certainly water is no exception to that. And in an acid here, hydrogen again acting as a +1 ion, and oxygen acting as a -2. All right, so without oxygen and hydrogen in weird states, it can't be redox. Even if sulfur were oxidized or reduced, there's nothing else to be. So we're actually expecting sulfur to have the same oxidation number in each case, and it will. You can't have an oxidation without a reduction. So we can't have sulfur be one or the other. It has to be neither. And if you look at the sulfur dioxide here, that's got to be a +4 to balance the -4 on the oxygen. And if you work out the compound here as being neutral, we have +2 from hydrogen, we have -6 from oxygen. So of course we're missing a +4 from sulfur. So nothing changed here. This is not a redox reaction. All right. Number 15. So first thing we notice is this is definitely an other reaction. There's so much stuff going on here. There's way too many materials to fit into any of our simple 5 types of reactions. Okay? It's not a combustion, a synthesis, a decomp. There's too much stuff for single and double replacement. So this is a more advanced type of a redox reaction. Or at least we're looking for redox here. And remember the guidelines. Look for elements first. Okay, there are no elements in here, so that's not going to find redox. Non-metals are good possibilities. All right, not oxygen, of course, and not hydrogen. There is a non-metal here, which is nitrogen. Right? However, if you look, nitrogen is in the nitrate form here, and it's in the nitrate form here. So although we often look in nonmetals, there's no change of species, so that's not going to be redox. Okay. The other possibility is transition metals. Transition metals often change in charge. And we've got lead here and lead here, so that's a possibility. And in fact, if you know your ions right away, this is lead 4. Okay? In other words, the lead here has to be a +4 oxidation number because there's 2 oxygens at -2, and lead has to balance it. And over here, this is a lead 2 ion. So if we come all the way over here, this lead has to be +2 because it's combined with 2 nitrates, and each nitrate is a 1- ion, so lead has to be the +2 ion. So there's our reduction, lead going from +4 to +2. So where else do we look? Well, there's another transition metal here, manganese here and manganese here. Okay? And again, transition metals are often found in very different oxidation numbers, so this is almost definitely going to be our oxidation. Right? And notice we already have a reduction, so we're looking for an oxidation. And again, we're not counting on hydrogen or oxygen. We already ruled out nitrogen because it's part of nitrate. So let's work with the manganese here. And in this, you could probably work with these as compounds, being neutral overall. So we have 2 positives here, and we have 6 negatives here. So we're missing 4 positives. All right, so that manganese has to be +4 to balance out the charge here. And over here, this would be called permanganic acid. Okay, that's the permanganate ion. And so this is an acid we don't use often, but with hydrogen in front, it's permanganic acid. This is a different acid that we wouldn't know the name of with our naming system. All right. But if hydrogen is +1 here and oxygen is -2, making a total of -8, we are missing +7 here. Okay, so the manganese has to be +7. And sure enough, that's our oxidation, from +4 to +7, an increase in oxidation number. And lead was reduced from +4 to +2. So I hope that helps. Again, if there are any others you feel you need explained, you can always ask me to make a video, and I'd be happy to.